finally, the unit you've all been waiting for, financial planning. I think this one's called the investment unit. So what we're going to look at in this unit is basically how do these calculations happen. If you're trying to find everything from simple interest to future value or payments that you need to make on loans, or if you want to have so much money left when you're done, how much do you have to make for each payment. So this is called financial math, investing money. So what we're going to look at first is just the real basics of financial math, and that's just calculating simple interest. So, a few terms, there's 8 different terms here that you're going to come across, not only in this section, but throughout the this unit. So the first one is a term. So a term is just the contracted duration of an investment or a loan. So at school we talk about our terms as being term 1, term 2, and then we figure out your marks for each term. So terms can be used in, or that term can be used in many different ways. In this particular unit, it's going to be talking about how long something is either invested or borrowed. Interest then is the amount of money earned on investment or paid on a loan. A fixed rate of interest, or fixed interest rate, is the rate that is guaranteed not to change during the term of an investment or a loan. So if you take out a loan and you have a fixed interest rate for 5 years, then you pay whatever that rate is for 5 years. If your loan needs to be extended, then your interest rate will change based on whatever it is at that time. Principal is just the original amount of money invested or loaned. Simple interest is the amount of interest earned on investment or paid on a loan based on the original amount and the simple interest rate. Maturity, the contracted end date of an investment or a loan at the end of the term. So a lot of times when they talk about maturity is when you do an investment. Your investment will mature in 5 years. So that means in 5 years after you've invested that money, you can pull it out or you can reinvest it. Future value, and I missed the little symbols here too. So simple. An interest is always going to be, whenever you see that little I, that stands for interest. A capital P is principal. Future value is A, is always going to be symbolized by the capital A. So future value is the amount that an investment will be worth after a specified period of time. Rate of return is the ratio of money earned or lost on an investment relative to the amount of money that was invested, usually expressed as a decimal or a percent. Okay, so to determine simple interest only, we use the formula I is equal to PRT. So you would have come across this one. I know in our old math, in the old math curriculum, we used to teach this like in grade 7, 8. I'm not sure if it's still in the new one. I can't remember it in the grade 8, but that's about where you learned about simple interest. So I is equal to your interest earned or interest paid. P is your principal or initial amount. R is your rate of interest. And T is time in years. So to determine future value using simple interest formula, it's A is equal to P times 1 plus R times T. So instead of just being P times RT, it's 1 plus that. So where A is equal to your future value. Another way to write this is if I actually just distributed that P, so I'd A is equal to P plus PRT. Oops, that should be a little R. So it's your original principal plus the interest that you've earned on it. Some other terms that you're going to come across in this unit is when they're talking about compound periods or how often something interest is applied to something. So annual means that it's once a year. Semi-annual means that that'll occur twice a year. Monthly is then 12 times per year. Weekly would be 52 times per year. Daily is 365 times per year. We'll also come across some bi-monthly and bi-weekly ones that we'll deal with later on in the chapter. So let's do some investigating. So Sarah is 20 years old and needs money to pay for college. When she was born, her grandparents bought her a $500 Canada Savings Bond, CSB, with a term of 10 years. They chose a CSB as an investment because they liked the security of loaning money to the government. The interest earned was determined using a fixed interest rate of 6% per year on the original investment and was paid at the end of each year until Sarah's 10th birthday. So Canada Savings Bonds are still offered, and what they are is basically you're buying this bond, the money goes directly to the government uses it to pay for whatever infrastructure, those types of things, but you're guaranteed that money back. It's not like another investment where if you invest $500 every year, that $500 could grow or it could, depending on what the markets are like, you could lose that money. So how can we determine the current value of Sarah's Canada Savings Bond? So we know we're looking at an interest rate of 6%. So when you're doing these, that's exactly what you want to do, is you want to identify your variables. So I know that this is, I'm using my I is equal to P or, oops, I keep wanting to put my P and R together. So my PRT formula. So from here I know my interest is 6%. The principal, so the initial amount that they bought for her was $500. So that's not my I. I'm trying to find out how much interest I'm going to earn. My rate is the interest rate, which was 6%, and the time was in 1 year. So every year, because this is how much interest was earned on the principal by the end of the first year. So in 1 year, I have interest is equal to 500 times 6%, so times 0.006 times 1 year. So that is equal to $30. So in 1 year, she will earn $30. So B part says, determine the simple interest earned each year, the accumulated interest, and the value of the investment for the first 4 years. Organize your calculation in a table. So the very first year, year 0, they put the money in. Value investment at the start of the year in money, so they haven't invested money yet. Simple interest earned, none. Accumulated interest, none. Value of the investment at end of year, so $500. So they just started this. So 1 year in, they've invested their $500. We know the simple interest that they earn every year on that $500 is $30. So the accumulated interest so far would be $30. So at the end of the year, she has $530. Year 2, she starts at $530. She's earning $30 interest every year, so that means she will have accumulated another $30, so she'd be at $60 interest. So at the end of that second year, she would have $560, or it would be worth $560. So year 3, she starts the year with $560. She's going to earn another $30 for a total of $90 interest earned. So her total investment is now worth $590. Year 4, She starts at $590. She's always earning that $30 because it's 6% on the initial investment. So she's now at $120 interest. So she has an investment at the end of the 4th year of $620. So then it says, is the simple interest earned each year constant or variable? Explain. So if it's constant, that means that she's earning the same amount of interest every year. If it's variable, then that means that that interest rate is changing. So this is obviously constant because the interest doesn't change. So it says, describe the relationship between the number of years the interest earned each year and the accumulated interest. So if we look here, we have the number of years times the interest earned equals the accumulated interest. So if we take our years times our interest earned, that equals our accumulated interest. So we had 4 years times $30 interest earned gave us $120, which was our accumulated interest. So it says use the relationship for part D to predict the value of the investment after 10 years. So after 10 years then, if this is the pattern that this goes, then we would have 10 years times our $30 to be $300 in interest earned. So the total investment then would be that 500 plus 300 interest. So in 10 years, would be worth $800. Okay, F says, graph the growth of the investment until its maturity at 10 years using time and years as the domain and the value of the investment $sign as the range. Is your prediction in part E supported by your graph? So if we do this, our domain, our X values here, is our time in years. And our range is our value, or our Y values of investment. So if this is 0, 2, 4, 6, 8, and 10, and if we go starting at, so this would be 100, 300, 500, 700, 900, we'll go up to 1100. You don't really need to go that high. And we plot this. So at year 0, we started at 500. Well, you know what? Sorry, I'm going to make this a little bit because it's going to be hard to show our $30 increases there. So I'm actually going to start this because we know since it doesn't start till 500, we'll just start right at 500 here. And if we go 1, 2, 3. So every 4 blanks we could put at put up $100. Okay. So year one, we were looking at, or sorry, year zero is our initial $500 investment. Year one, you've earned $30. So $30 would be, if this is going up by 25s, right? 25, 50, 75, 100. So year one, we're looking at just a little over there. Year two, it's gone up $60, so it'll be a little bit over there. Year three will be at $90, so it'll be almost at the top. Year four would be $120, so just below. Year five would have $150. Year six would be $180. Year seven would be $210. Not quite halfway. Year eight would be $240. So just below that $250 mark. Year nine, what's 9? So it's $270, $250, so just about there. And then year 10 was $300, so it was about there. So it's a linear progression. So according to what I calculated there, at year 10 I should be at $300 interest, so a total of $800. If this was if I could draw a straight line, we'd see that this does make a perfectly straight line that would continue on. So what we've really drawn here is a straight line which has a slope and a y-intercept point that we could calculate. Now again, because my points are kind of approximate, it's not going to look exactly like that. But basically what we've done here is we've drawn a graph of y is equal to my changing amount, which was, I went 30 times for every year, and my initial investment, or my y-intercept, was at 0 and 500. So I could plot in whatever number I wanted to in there and find out what this is worth in 20 years. Or I could go just based on my line to find out when it would reach 900. If I were to continue my line on here, it kind of looks like at this year here, and that's if my line was straight, which would put me at about year, what's that, 10, 12, year 14, where I would be at that $900 value. Now again, that's if my line was nice and straight. I might be a little bit off. It might be actually at year 15. Okay, solving simple interest problems. Marty invested a $2,500 guaranteed investment certificate, so GIC at 2.5% simple interest paid annually for 10 years, with a term of 10 years. How much interest will accumulate over the term of Marty's investment? Use the formula I is equal to PRT, where I is interest, P is principal, R is rate, as a decimal, and T is equal to time. So we're trying to find out the I, because we want to know how much interest. Our principal was $2,500. Our rate as a decimal was 2.5%, so that's 0.025, and our time is 10 years. So using our I is equal to PRT, I have 2,500 times 0.025 times 10. So my interest earned in 10 years would be $625 total. So future value, what is the future value of his investment at maturity? So future value is equal to your principal plus your interest. Oops, not. So remember, future value from our formula there was your principal times 1 plus the rate of interest. So we already did this calculation. So we can just say it's principal plus the interest, so 2,500 plus 625. So the future value of this investment would be 3,125. So all the future value is just adding your interest earned onto your initial investment. Sunny invested $15,000 in a savings account. Sunny earned a simple interest rate of 8%, paid semi-annually, which means twice a year, on her investment. She intends to hold the investment for 4.5 years, when she will withdraw all the money to buy a car. Determine the value of the investment at each half year until she withdraws the money. So it wants to know how much she's going to have at the end of 4.5 years. Our principal amount that she's investing is $15,000. Her rate of interest was 8%, so 0.08. The time that she has, so remember your time is the number of interest periods that you have. So in this case, because it's semi-annually, so it's being paid out twice a year for 4.5 years. So this is 4.5 times 2, so that is equal to 9. So using our simple interest formula, interest is equal to our 15,000 times our 8% times 9. So $600 of interest is being earned. So every time interest is being applied to this account, it's being applied in the amount of $600. So to find out how much this investment is worth at each half year until she withdraws the money, we're not going to do this down here. I'm just going to do it as a table. So if this is the year, and this is the value of interest, so at year 0, that's her investment, was $15,000. Halfway through the year, she was paid $600. So her, so it's worth $15,600. At the end of 1 year, it would be worth another $600. So this would be $16,200. At 1.5, it would be worth another $600. So this would be $16,800. And another half year, it would be worth another $600. So that'll be $17,400. Another $600. So that's going to be $18,000. Oops, I didn't make my table quite long enough. So another half year, we have $18,600. So this will be $19,200. At 4, it's going to be $19,800. So her final amount will be another $600. So $20,000. Sorry, I can't get my math right. $400 is her final amount that it's worth. Because that's the interest paid. The simple interest is telling you the interest paid at each interest period. Ingrid invested her summer earnings of $5,000 at 8% simple interest paid annually. She intends to use the money in a few years to take a holiday with a girlfriend. How long will it take for the future value of the investment to grow to $8,000? So she wants it to be $8,000. So this is a future value here. So if it's a future value, then that means that $8,000 is equal to our A. We know that the principal amount she invested was $5,000. Her rate of interest was 8%. But what we don't know is the time. We want to know how long. So that is what we're trying to find out, is our time. So using our future value formula, and because they've given us our principal, remember there's two ways of writing it, is P times 1 plus RT, or P plus PRT. That's the way we're going to write it, because then we only have one thing to solve for. So we know A is 8,000, principal was 5,000, plus 5,000 times 0.08 times t. So to solve, I'd move my 5,000. So I have 3,000 is equal to 5,000 times 0.08 t. So divide by 5,000. So 3/5 basically is what I'm at. Oh. Okay, I'm two ways to solve this. I'm going to finish solving it this way. So I have 3 over 5 is equal to, I'll leave it like this, 0.08t. So if I divide by 0.08 and divide by 0.08, this leaves me with 7.5 is equal to t. The other way to have solved it, which actually would have been better, is if I had right here in this step multiplied this through. So when I move that over, I should have said that this is 3,000 is equal to 5,000 times 0.08 is 400. And then I'm not working with that funny decimal. I'll still get the same answer when I'm done, because 3,000 divided by 400 is still 7.5, as is when I divide 3 by 5 and then times it by 0.08. So either way still works, but the other way would have been better. So the question was, how long will it take for her to grow this to $8,000? So 7.5 is our T, but remember this interest is being paid out annually, so we have to round up. So it will take her 8 years. So it's going to take her 8 years to save for that trip. Okay, so it says, what is Ingrid's rate of return? So to find her rate of return, we need to first calculate what is that future value. So if we did it for the 8 years specifically, what will her future value be? And then we need to find out what is her rate of return based on how much interest she's earned over the principal she's invested. So the future value for this so our principal was $5,000 times 1 plus 0.08 times 8. I did that in a bad. There, I'll double bracket it. So this is 5,000 times 1 plus 0.64. So 5 times 1.64 is 8,200. So this, by the time those 8 years is over, she'll have a little bit more than that 8,000. She'll have 8,200. So what is her rate of return then? Her rate of return is going to equal, and I'll just put this as an RR, the interest that she's made divided by the amount she's invested. Oops, or her principal. So this is equal to the interest she's earned, so she's going to end up with $8,200. So she's earned $3,200. She invested $5,000. So that equals 0.64, which is 64% rate of return at the end of the 8 years. And if you look, that is exactly what we got here. Okay, just some summary here. Simple interest is determined only on the principal of an investment, so you're not, simple interest, when you're calculating that, you're not taking into account that you're earning interest on the interest, okay? The value of an investment that earns simple interest over time is a linear function, so when we're looking at simple interest, when you plot this out, it will always be a line, and once you've plotted out some of your basic points and kind of figured out what your slope is, you can then predict what future values would be based on where it is on that linear progression. Since the interest is paid at the end of each period, the growth is not continuous. For example, the following graph shows principal of $3,000 invested at 5%, interest paid annually over 10 years. So the value of the investment, so you start at $300, and every year you're earning another 5% of 300 would be $15. So every year you're earning another $15. So it says accumulated interest over time. That's the second chart. Then you can calculate. So at year 0 here you had 15. Year 2 you had 30. Year 3 you had 45, and so on and so on. And then finally, when you got all the way up to year 10, then you actually made $150 interest. So the amount of simple interest earned on investment is just I is equal to PRT. Future value, or A, is of an investment that's earning simple interest is just that A is equal to P plus PRT, or A is equal to P times 1 plus RT. So it's the same thing, just depends what you're given and what you're trying to find out. So unless it says otherwise, interest rate is assumed to be an annual, so once a year. Even though interest rates are usually annual, interest can be paid out in different intervals, such as annually, semi-annually, monthly, weekly, and daily. So if over the course of a year you earn $300 interest, if that $300 is paid out semi-annually, twice a year, then that means you'll get $150 in the first half of the year, and then the other $150 in the second half of the year. Okay, those are your questions.